I welcome you all in this presentation related with the subject materials processing fundamentals and practical, and we are talking about the metal casting. So, in this particular presentation I will be talking about the casting processes. So, there are three very common casting processes which are used in industry, and about that I will be talking little bit in detail, the way by which these processes are performed, or how these processes affect the soundness and the quality of the casting that is produced. So, as far as content is concerned, like we will be talking about the sand mold casting, where the sand mold is prepared, okay, using the suitable sand, okay. And then in die casting, where the mold is made of the die, okay. So, this the mold is made of the metallic die, okay. So, therefore, it is termed as the die casting, and this die casting can be performed under the two conditions, where the molten metal is fed under the gravity, or the molten metal is fed under externally applied pressure. Accordingly, gravity die casting or pressure die casting it is termed as, okay. Then depending upon the condition in which the molten metal is maintained before feeding into the mold, like it can be hot chamber or it can be cold chamber die casting, okay. So, in case of the hot chamber die casting, the molten metal is heated when it is stored before being pushed into the mold. But in case of the cold chamber die casting, there is no external heating of the molten metal when it is stored. So, it is fed, molten metal is fed from the ladle into the chamber, and then with the help of the plunger it is pushed into the die for developing the casting. So, the hot chamber die casting is mainly used for the low melting point metals like zinc, magnesium, etc. Okay. And then investment casting, this is particularly used for making the complex shape jobs and the models, statues like this. But this is primarily used at the low scale for making this kind of the product. So, we will be talking about the various aspects associated with these three processes: sand mold casting, die casting and investment casting. These processes differ in terms of the material used for making the mold. Okay. As I said, in sand mold casting we will be using sand, in die casting we will be using the metal, and in investment casting it is basically the ceramic material which is used. So, this difference in the material of the mold which is being used in these three different types of the processes, that brings in significant difference in terms of the which in turn affects the quality of the casting being produced. Quality of casting produced is significantly affected by the factors associated with these three processes due to the difference in the mold material is like the heat transfer rate, which governs the cooling rate experienced by the molten metal during the solidification, and the second one like the time for escaping the gases, okay. If the time is less, then gas entrapment tendency is more, okay. And because of the difference in the cooling conditions experienced, we get the significant difference in the microstructure, especially the grain size that is observed, and that in turn affects the mechanical properties. Okay. So, all these processes differ in terms of the cooling conditions, the kind of the time available for escaping the inclusions and the gases dissolved, and the difference in cooling rate affects the microstructure and so the mechanical properties. Okay. These things we need to keep in mind while talking about the various processes. As far as the sand mold casting is concerned, we know that the molding sand is used for making the sand molds. So, which is basically the green sand, clay which acts as a binder, water and some additives are used for imparting the specific set of properties like high permeability or the refractiness or the good surface finish like that. Okay. So, we have to see like what is the type of the sand, okay, and the size range of the sand particles, okay, the type of the clay which is being used, because the different clay offer the different kind of the refractoriness or thermal stability, okay, the water, because water also affects the strength of the mold, and then additives. So these additives will help in developing the specific kind of the properties. So depending upon the kind of combination of the sand size range, the type of clay and water which is being used, okay, we have to see that what kind of the mold of the sand is being made, because it affects the permeability associated with the mold, okay, which determines the is escaping of the gases dissolved in the molten metal, and that in turn affects the soundness in terms of the reduction in porosity. If escaping is good, the gases dissolved or the gases present in the mold will be able to come out of the mold easily due to the good permeability, then the porosity will be reduced, okay. And likewise the strength is the another important factor. If the strength of the mold is good, then it will retain its size and shape. Otherwise, these can get modified due to the swelling, or means the movement of the mold walls under the pressure of the molten metal, or metallostatic pressure of the molten metal, or these the shape and size also can change due to the erosion caused by the flow of the molten metal. So, if these characteristics are the good, then we will be able to have the sound, the casting. Then another aspect is this, the refractoriness, okay, which will depend certainly on the size of the sand and the type of the sand. Refractoriness, if the refractoriness of the sand mold is less, then it will tend to fuse and mix with the molten metal. Once it is mixed, then it becomes the part of the casting. So wherever this sand has melted, it will be resulting in the very formation of the very hard spots, coupled with the change in shape of the casting. So if these things are happening, then the will be getting the casting of the shape which is not desired, or will be getting the casting having the surfaces which are extremely hard, difficult to post process or machine, okay. Therefore it is very important that there is no fusion of the mold surfaces during the casting, okay. So we have the mold of the desired size and shape with the desired characteristics in that mold. When we feed the molten metal, okay, so when on feeding the molten metal, of course it will be having the gases dissolved, or gases which are present in the mold, coupled, and once these are there, and there is a possibility of few inclusions also. So the heat dissipation from the mold wall will start, okay. Since the thermal conductivity K of the mold wall is less, so it will be dissipating the heat slowly. So the cooling rate that will be experienced by the molten metal will be less. So due to the low cooling rate, it will take long solidification time. Long solidification time means it will take a long time to complete the solidification. So the production cycle will be delayed, and that in turn will reduce the productivity. This is one aspect, okay. Apart from that, when we work with the low cooling rates, then in case of the low cooling rates being experienced by the molten metal, this promotes the low nucleation rate and the high growth rate, and this combination results in the coarse grain structure. If we are having the coarse grain structure, then our mechanical properties of the casting are compromised, okay. So it is very important that, so this is how our sand mold will be affecting the casting characteristics, okay. Now the feeding of the molten metal in the sand mold is crucial, okay. So why it is? Because there should not be any kind of the turbulence in flow of the molten metal. When molten metal is fed, there should not be any turbulence in flow of the molten metal. If there is a turbulence, then there will be increased dissolution of the gases in the molten metal and increased tendency of the erosion of the mold wall. So, the things will, the mold will get damaged or the more gases will get dissolved. So, these will promote the defect in form of porosity and inclusions, and erosion of the mold wall will change the shape of the casting. Okay. So, as I said, since the solidification time is long due to the low thermal conductivity of the mold wall, it takes long to complete the solidification. Okay, like this. Okay, here solidification starts, here it ends, like this, here it ends. So, this time start to end is long in case of the sand mold casting because of the low thermal conductivity and the low rate of the heat transfer or dissipation from the molten metal to the mold wall. Once the solidification is completed, okay, once the solidification is completed, then the mold is broken. Okay. So, this must be broken at the right temperature, so that we must allow the casting to cool down to sufficiently low temperature, so that it gains the strength. Otherwise, while breaking the mold, the component or the casting can also break. So, the removal of the mold is done by breaking the mold. So, this must be done at the low enough temperature to avoid any kind of the distortion or damage to the casting which is being made. And once the component has been produced, then it will be obtained, then it is cleaned to remove all unwanted parts, components, and by using suitable methods, and then it is inspected for the soundness and the general size and shape of the components. Okay. There are few aspects like low cooling rate associated with the sand mold castings, okay, results in the long solidification time. Long solidification time gives the enough time for escaping of gases, as well as it gives enough time for inclusions to float over the surface, come up to the surface. So, the entrapment tendency for the gases and inclusions is somewhat reduced. So, the porosity and inclusion forming tendency due to the low cooling rate is reduced, okay, in case of the sand mold casting, because we have enough time for escaping of the gases if there is enough permeability. But low cooling rate on the other hand will result in the coarse grain structure, and that in turn will be leading to the reduced mechanical properties. Okay. Now, we will be looking into the die casting. Die casting means where the metallic die is used as a mold. Okay. So, this can be of cast iron or this can be of the brass or steel. They offer a relatively high thermal conductivity. So, high thermal conductivity offers the higher cooling rate. The rate of heat dissipation from the molten metal to the mold wall is very high. So, that in turn results in the higher cooling rate. Okay. Higher cooling rate means the less reduced solidification time. Reduced solidification time means increased tendency for the less time for escaping of the gases, less time for escaping of the gases and inclusions. So, there is a possibility that entrapment of the gas and inclusion tendency will be more due to the lesser solidification time. But on the other hand, the high cooling rate which is realized during the die casting results in the higher nucleation rate and the low growth rate, okay, and low growth rate, and this in turn results in the fine grain structure, which in turn results in the good combination of the mechanical properties. So, as I have said, these in die casting we use the metallic dies, so these can be used multiple times, okay. Therefore, these are good for the high volume production, okay, when large number of the units are to be produced. So, the die casting uses permanent metallic mold for mass production, Okay, molten metal for die casting in the mold is fed and solidified either under the gravity or under the external pressure. Okay, so when the molten metal is fed under the gravity, it takes long to fill the cavity. Okay, but when we use the pressure, the filling time is reduced significantly. So this is one. So the conditions under which the molten metal is fed affects the time for filling of the mold by the molten metal, and that in turn affects the productivity. Okay, in the pressure die casting, molten metal is fed to the mold rapidly, which increases the productivity by reducing the casting cycle time. Okay, so accordingly we will be defining it as a press gravity die casting when no external pressure is used and under the gravity molten metal is fed, press gravity die casting, or when the molten metal is fed under the pressure, then it is termed as pressure die casting. Okay. So, as I have explained, the solidification of the molten metal under the pressure conditions minimizes the tendency of the casting defect and increases the soundness. Okay, this is an interesting part. And the fast cooling of the molten metal due to the rapid heat transfer from the molten metal to the metallic mold produces the fine grained structure, and that in turn improves the mechanical properties. About this we have already said, like in die casting, when we use the metallic mold, it allows the greater cooling rate and so the finer grain structure and better mechanical properties. Very high cooling rate may promote the entrapment of the dissolved gases and inclusions due to the limited time availability for escaping of these things. Okay. So, in one side, the faster cooling rate is good for producing the fine grained structure and better mechanical properties, but it may increase the tendency of the entrapment of the gases and inclusions. Okay. In die casting, the molten metal can be fed in two ways. One, where the molten metal, okay, the molten metal which is fed from the ladle is either heated continuously in the chamber, and therefrom it is fed to the die, or it is no extra heating. Okay, from the ladle molten metal is fed into the chamber and then it is pressurized to feed into the die for producing the casting. So, no external heating actually. So, when there is external heating using either resistance heating or induction heating, it is known as hot chamber die casting. Otherwise, it is known as cold chamber die casting when there is no external heating. Okay. So, this hot chamber die casting is preferably used for the low temperature melting point metals like zinc, magnesium, etc. So, molten metal is kept in a chamber, like say there is a chamber. Okay. Now, in this there is a chamber. So, if we continue to heat it using external heat source like resistance or induction heating approach, then this will be the continuous hot chamber die casting, or if there is no external one, directly the pressure is applied in the chamber for filling the mold cavity, and then accordingly it is termed as the hot chamber or cold chamber die casting. The molten metal is kept in the chamber where from it is fed to the mold, which can be heated using externally, which can either be externally heated using the induction heating to maintain the proper temperature of the molten metal in the chamber, especially in case of the low melting point temperature metals like magnesium, zinc, lead and tin, and or it is stored, the molten metal is stored without any external heating, and in this case the pressure is applied directly for feeding the molten metal into the die, okay, metallic mold. So, this no external heating, and this is used for a little high melting temperature metals like the aluminum. Okay, hot chamber die casting, since there is a continuous heating option for maintaining the temperature of the molten metal at correct level. So, it allows to maintain the temperature of the molten metal correctly before feeding. Okay. Hot chamber die casting helps to feed the molten metal to the mold at a right temperature, and that in turn helps in improving the quality of the casting which is being produced. So, this is just a schematic of arrangement, like say this is the chamber where the molten metal is kept. okay, and then it is heated using the external heat sources, can be resistance heating or it can be induction heating for maintaining the proper temperature of this molten metal. Okay, then there is a piston and cylinder kind of the arrangement. So here the molten metal will be filled in this cylinder, and when it is full, then the piston moves down, that is moved with the help of the ram. So it builds up the pressure, and this the molten metal will be fed through this the channel to the die. So initially the die cavity, say, which is having the two parts in this case, the fixed half and movable half. Okay, so and this is the die cavity where the molten metal will be filled in. This is the split die. Okay, one half is fixed, another half is movable. Okay, so when the piston moves down, the pressure molten metal in the cylinder is pressurized, that is called short chamber, and it is pressurized and it moves through this feed line to the die cavity. And when this the piston moves down, this the molten metal is fed into the die cavity. Die cavity will be filled in completely by the molten metal. Okay, and once the solidification is over, then the what is done, this movable die is taken back, and with the help of the ejector pin, casting is taken out. Okay, so this is the kind of the arrangement for the hot chamber die casting. In hot chamber die casting, the molten metal is heated continuously, then with the help of short chamber, the molten metal is pressurized to feed into the die cavity, and then the piston will be moved up again the process is repeated. Okay. In cold chamber die casting, what we do, there is a the short chamber. Okay. In the short chamber, molten metal is fed from the ladle into the short chamber. This is the like piston and this is the short chamber. You can see kind of piston cylinder assembly, and then the ram will be moving the piston, okay, to build up the pressure. This is the die cavity, and here what will have, when the piston moves towards the left side, pressure will be built up. Okay, and so the molten metal through this channel will be filling in the die cavity, okay, in this zone. So that's what we can see here, the ram has moved, okay, and this piston has built up the pressure, and so the molten metal has been pushed under pressure to fill the die cavity quickly. So in both these cases, if we see whether it is hot chamber or the cold chamber die casting, pressure is built in the short chamber, okay, using the suitable cylinder and piston kind of the assembly. So this allows the feeding of the molten metal under pressure, molten metal to the die under pressure, and when it is filled under pressure, it takes very less time to fill the mold cavity. Okay. So now we will see the investment casting related things, and here in investment casting, this process is preferred for making the complex shape products with the relatively good surface finish like statues, models, and many engineering components using relatively low melting point material. So investment casting, the key thing here it uses the ceramic mold, okay, but this ceramic mold is prepared with the help of the wax pattern. Okay, so once first we prepare the wax pattern, and then this wax pattern is used for making the ceramic mold, and once the ceramic mold is ready, then the molten metal will be filled into the ceramic mold. Since the wall thickness ceramic is of the low thermal conductivity, wall thickness is also less. So, the heat dissipation from the molten metal in case of the ceramic mold is very less. The rate of heat dissipation is very less in case of the ceramic mold, and therefore, the cooling rate that is experienced is very low, and that in turn results in the coarse grain structure, and so the reduced mechanical or poor mechanical properties. This is how we can understand this. So, so the first step here in the investment casting is this also like the mold is prepared for one use only, it has to be broken for subsequently after making the casting. So, the first use is here to make the pattern, okay, pattern is made of the wax, okay, and this wax pattern will be used for making the mold. Okay, mold of ceramic. Once the mold is there, then the filling of the molten metal in the mold. Okay, and then after the solidification, the casting is done, and then once the solidification is over, the mold is broken and the casting is taken out. But making this process of the pattern is little complicated because we use the wax pattern here. So first of all, what we have to do, we have to prepare a metallic mold, and in the metallic mold the molten wax will be filled in so that the wax pattern is obtained, and wax pattern it will then later on will be dipped in the ceramic slurry. Okay, ceramic slurry, and in the slurry then will be sprinkling or putting the ceramic powder. Okay, for realizing the desired thickness of the mold wall, and once this is achieved, then we'll be doing the baking to impart the desired strength, and then our the mold ceramic mold will be ready, and in that ceramic mold we'll be putting in the molten metal for realizing the casting. So the steps of the investment casting goes in like this: preparing the pattern made of wax via casting route first, using how it is made. First, it uses the metallic mold, and in which the molten wax is poured in the metallic mold, and after the solidification and post processing of the wax pattern, like the finishing and joining, the wax pattern is made. Okay, so we use initially the metallic mold for making the wax pattern, and followed by solidification, then post processing like finishing and joining to get the desired pattern of the desired size and shape. Okay, once the pattern is ready, then next job is to make the ceramic mold. Okay, so developing the mold using the wax pattern, that's the next step. Dipping the wax pattern into the binder slurry, followed by application of the refractory powder particles for bonding to obtain the refractory shell, which is later baked for hardening of the refractory shell and the removal of the wax. So once the shell is ready, it is heated so that the wax is removed and the refractory shell is left behind. This refractory shell acts as a ceramic mold. Okay, now the in the ceramic mold we will be pouring the molten metal in the refractory shell mold, followed by solidification of the molten metal to produce the casting. Breaking of the refractory shell is necessary to take out the castings, and after taking out the casting, it is cleaned and inspected just like in normal way. These are the schematic steps which are shown, like how the things are done in the case of the investment casting. Initially, the first step is to make the metallic mold. Okay, this metallic mold will be used for making the wax pattern. So, the molten wax will be filled in the metallic mold. So, this is the second step, is the molten wax is filled. After solidification, we get the wax pattern. Okay, we get the wax pattern. This wax pattern will be dipped into the slurry. Okay, binder slurry. Okay, so the fourth step is the binder slurry, in which the wax pattern will be dipped in. So this slurry will be forming the kind of coating over the wax like this. Okay, this is the slurry. Okay, now over this slurry coating will be applying the ceramic refractory powder particles. So it will be sprinkled. So the powder particles will be getting bonded with the binder agent present over the surface of the wax pattern. So this is that step where the ceramic powder particles will be sprinkled so that they form a kind of shell. Now this process will be repeated until we get the wall of the desired thickness. Okay, slurry coating, like dipping the pattern into the slurry, then sprinkling the refractory powder particles over the slurry to realize the the coating the shell of the desired thickness. Once this is achieved, then what will be done? Will be doing the baking. Okay, baking will help in hardening of the shell as well as removal of the wax. Okay, because wax will be melting, so this wax will be removed. So at the end, we'll be getting at the eighth step, ceramic shell, which will be used as a mold, is obtained. In this ceramic shell, we will be filling in the molten metal. So this molten metal has been filled in, and that molten metal on solidification will be giving us the casting of the desired size and shape. Okay, so these are all steps which are used for making the investment casting. So first, metallic mold, okay, and then the wax pattern, and then wax will be filled in to for producing the wax pattern. This is the wax pattern, and then the wax pattern is dipped into the binder slurry. Okay, and this binder slurry, so it is taken out, so it will, the slurry will be all around the wax pattern, and then we'll be coating or applying the refractory powder particles, and this process 4 to 6 is repeated until we get the ceramic wall of the desired thickness. Then it is baked. That's the next step. After baking, the wax will be removed and the ceramic cell will be hardened. Okay, and so we get the hardened ceramic shell at the step 8, and then in the ceramic shell the molten metal will be filled in of the cast molten metal of the material whose casting we want, and then on solidification we will be getting the final casting. Okay, then it will be cleaned and inspected for the desired characteristics. So these are the all steps of the investment casting. Now we can see here, since the in investment casting, since the molten metal is made of very thin wall of the refractory or ceramic material, therefore rate of heat transfer from the molten metal to the mold is very low. Low rate of heat transfer causes the longer solidification time, and low cooling rate therefore results in the coarse grained structure and the relatively softer phases. Okay, suitable, and to avoid the coarse grained structure and softer phases, what we can do? We can do suitable alloying of the grain refiners. They will help in realizing the finer grain structure and improved mechanical properties of the investment casting products. Now, I will summarize this presentation. In this presentation, basically, I have talked about the approaches which are used in the three types of the casting process and what are the various aspects to be kept in mind for developing the sound casting. Thank you for your attention.